It may be necessary for you to convert between concentration units. So you might be provided with a mass percent, which is the mass of solute per mass of solution, and asked to find a molarity, moles per volume. This kind of problem is essentially a dimensional analysis problem, where we have a particular unit and we're trying to get to another unit. And what's nice about these types of problems is we can often use the units as a clue to get from where we're starting to where we want to go. And that's the great thing about keeping track of your units, is that they can be very helpful. So let's consider this problem where we have dilute aqueous hydrogen peroxide. We know that it's 3% by mass, and we want to know what the molarity of that concentration is. So let's set up what we know on this side. We have a 3% hydrogen peroxide by mass. And this is equal to 3 grams of H2O2 in 100 grams of solution. So remember that we're talking mass of solute divided by mass of solution. And then we want to go to a molarity, a moles per liter, okay? And we're gonna need some number of unit conversions to get there, right? I put in 3 boxes. Hopefully we don't need more than that. If we do, we can add more, okay? So put in some number of conversions that we're gonna plug in here to get from here to here. So we need to go from grams of hydrogen peroxide to moles of hydrogen peroxide. And grams to moles, we know that's molecular weight. So the molecular weight is 34 grams per mole for H2O2. So this will give me moles of H2O2. So I've taken care of the conversion of my numerator. I'm good. Now I need to go from grams of solution to liters of solution. So how do we go from a mass to a volume? Well, it's by the density. So if you have questions about density, head back to that skills check and see if you can work those sample problems. The density is given as 1.01 grams per milliliter. So I have grams of solution will cancel out. And now I have mils, and I'm going to liters. So there are 1,000 milliliters in 1 liter. And that gives me the units that I want, moles per liter. So if we plug these numbers into my calculator appropriately, we get 0.89 moles per liter. And we can write this as 0.89 molar. I'd like you guys to try a very similar problem. Try this example where we're looking at a 5% acetic acid solution and asking to find the molarity. So we know that there's a 5% acetic acid solution by mass, which means that there are 5 grams of acetic acid per 100 grams of solution. And I want to know molarity, so moles per liter. I need to convert grams of acetic acid to moles of acetic acid. So grams of acetic acid to moles of acetic acid. This is molecular weight. The molecular weight of acetic acid is 60 grams per mole. And that gives me the moles that I need for my answer. Then with the density, I have 1 gram per milliliter of solution. So 1 ml of solution would weigh 1.01 grams. That's how we go from grams to volume. And then we need our conversion from mils to liters, which is 1,000 milliliters in 1 liter. So this works out to give you a molarity of 0.84 molar. Again, we can write the units of molarity as capital M. So if you have questions as you're trying to calculate concentrations, either from measured mass data or by converting between units of concentration, please let me know. I'm here to help. And thank you for watching.